In this video, we will talk about the composition of the cosine function and its inverse, and this will include the inverse or the cancellation properties and examples. So let's start by reviewing the composition of two inverse functions, f of x and f inverse of x. Recall that from the definition of inverse functions, the composition of f and f inverse of x equals x, and the composition of f inverse of f of x is also x. Each of these properties have restrictions, and in the first one, this expression equals x if x is in the domain of f inverse of x. So this expression equals x when x is a number that can be used in the function inside the parentheses. The second expression equals x for each x in the domain of f of x. In other words, this expression equals x when x is a number that can be used in the function inside the parentheses. Now let's talk about the cosine function and its inverse. So the domain of the basic cosine function is any number from negative infinity to positive infinity. However, for the composition of the cosine function and its inverse, we need to use the restricted cosine function that has the domain from 0 to pi. So in the first column of this table, we have the restricted cosine function with the domain and the range, and in the second column, we have the inverse cosine function with its domain and the range. And because these two functions are inverses of each other, their domain and the range are interchanged. Now let's talk about the inverse or the cancellation properties. The first one is the composition of cosine and inverse cosine of x equals x for each x in the interval from -1 to +1. So this expression will be equal to x when this x is a number from -1 to +1. The second property is the composition of inverse cosine and cosine of x equals x for each x in the interval from 0 to pi. So in other words, this expression will be equal to x when x is a number from 0 to pi. Now let's analyze a few examples. Here we have 4 examples that we will simplify, and the first one is cosine of inverse cosine of 0.5. This expression starts with cosine and inverse cosine is in parentheses. Therefore, we will use the first property and we will have to check if 0.5 is in the interval from -1 to +1. And yes, 0.5 is in this interval. Then, according to this property, if x is in this interval, then whatever value of x we have here, the same will be the result. Then we can say that cosine of inverse cosine of 0.5 is 0.5. In the second expression, we have cosine of inverse cosine of 7. Number 7 is not on this interval, and inverse cosine of 7 is undefined. Therefore, the whole expression is undefined. Now, in the next example, we have inverse cosine of pi over 3. Here, inverse cosine is first, and then cosine is in parentheses. Therefore, we will use the second property. Let's start by checking if pi over 3 is in the interval from 0 to pi. And yes, pi over 3 is in this interval. Then according to this property, if x is in this interval, then whatever the value of x is here, the same will be the result. Then we can say that inverse cosine of pi over 3 is pi over 3. And now let's see the last example. Here we have inverse cosine of 5 pi over 4. 5 pi over 4 is not on the interval from 0 to pi because 5 pi over 4 is greater than pi. We can still evaluate this expression, but the result will not be 5 pi over 4. So we cannot use this property because x is not on the interval from 0 to pi. Now to evaluate this expression, we will start by evaluating cosine of 5 pi over 4. If we want to use the unit circle, then here we have 5 pi over 4, and this is the value of cosine. So cosine of 5 pi over 4 is negative square root of 2 over 2, and now we will have inverse cosine of negative square root of 2 over 2. Now, because the range of the inverse cosine function is any value from 0 to pi, then to find the answer, we have to look at this interval. So, what angle exists on the interval from 0 to pi whose cosine value is negative square root of 2 over 2? On this interval, here we have a value of cosine that is negative square root of 2 over 2, and the angle is 3 pi over 4. So then we can say that inverse cosine of negative square root of 2 over 2 is 3 pi over 4. Now we have all the examples completed, and thank you for watching.